The top speed of the Bugatti Veyron is 253.8 miles per hour. That is faster than a commercial aircraft takes off. And Matt Armstrong, a man who bought a broken Veyron from a UK repossession sale for under £1 million, just tried to hit it at a runway in Surrey. What happened next is the most complete record of Bugatti Veyron preparation ever filmed. Matt Armstrong has just posted the most ambitious video of his entire rebuild series. A new color, new wheels, a speed key he made himself for £20, a key that Bugatti charges over $10,000 to replace, and a top speed attempt at Dunsfold Runway, the same strip of tarmac that Top Gear made famous. But the attempt ended in a way nobody expected. And everything that happened between the workshop and that runway tells you more about what it actually takes to own and run a Bugatti Veyron than any manufacturer brochure ever will. By the end of this video, you will know every step Matt took to prepare this car. The wrap process, the wheel change, the TPMS workaround, the speed key creation, the fuse hunt, the misfire diagnosis, the accumulator replacement, and the one specific thing, not an engine failure, not a catastrophic mechanical collapse, something small, something entirely unpredictable that stopped the car dead after 150 miles of perfect driving at the exact moment it was ready to run. The Bugatti Veyron 16.4. Matt purchased it from a UK repossession sale for under £1 million. These cars trade on the open market for £1.5 to £2 million. In previous videos, Matt completed a full service on this car for £1,193 against a Bugatti dealer estimate of $20,000. He identified that the gearbox pump cross-references to an Audi A5 convertible, the spark plugs to a standard NGK part, the coil packs to a Volkswagen Phaeton or Bentley Continental GT. The car was mechanically running. This video was about taking the next step, transforming the car cosmetically, preparing it for a genuine top-speed attempt, and making it road-legal and road-ready for the first time since the rebuild began. Every step in that preparation became its own problem to solve. The Bugatti Veyron's top speed is not simply available whenever the driver wants it. In normal driving, the rear wing deploys automatically above 200 km per hour to generate downforce. That deployed wing creates drag. It limits the car to around 220 miles per hour. To reach the Veyron's true maximum of 253 miles per hour, the wing must remain retracted, the car must lower its ride height, and the aerodynamics must be configured for minimum drag. This mode is activated by a separate key, the speed key, inserted into a slot near the driver's door before the engine starts. Matt's Veyron came with only one key, the standard ignition key. No speed key. Bugatti's official replacement is rumored to cost over $10,000, plus a coding procedure at an authorized Bugatti service center. Matt had one question. What is actually inside the speed key? His team used a coil detection tool, the same type used to check whether a key contains a transponder chip. The result? Nothing. No coil. No chip. No electronics of any kind. The speed key is, literally, just a shaped piece of cut metal that turns a mechanical switch in the speed key slot. Matt took the ignition key to a locksmith, DPS at P1 Auto Keys. The machine read the cut pattern of the original Bugatti key. A blank blade was inserted. The machine replicated the pattern. The blade was assembled into a housing. Total cost, £20. It works because the key slot itself is not proprietary Bugatti engineering. It is a Volkswagen Touareg passenger airbag switch slot, the same component used in a mass-market SUV that costs a fraction of the Veyron's price, repurposed to enable the most exclusive top-speed feature in production car history. Matt's 20-pound key fits the slot. The slot does not know the difference. Within 1 mile of leaving the workshop, the car entered limp mode. The engine management light came on. Power restricted. Matt returned to diagnose. Cylinder 16 misfire. One of the W1616 cylinders was not firing correctly. At the same time, the indicators stopped working. Both stalks, left and right, produced nothing. The hazard lights worked. They run on a separate relay, but without functioning indicators, the car could not legally be driven on a public road. Both faults had to be resolved before anything else. Matt pulled up the interior carpet to access the fuse box. Dozens of fuses. No diagram identifying which fuse controlled which system. He tested every single one with a multimeter, continuity testing each circuit in sequence until he found the fault. A 5-amp fuse, pulled with pliers, confirmed broken. Replaced. Indicators restored. Then back to the misfire. Bugatti coil packs cross-reference to the Volkswagen Phaeton and the Bentley Continental GT. Matt sourced a Bentley W12 coil pack from a contact, Birdie, who drove it down at 11 o'clock at night to deliver it. The Bentley coil was fitted to cylinder 14. The original suspect coil was moved to cylinder 16. The misfire moved to cylinder 14. The Bentley coil wasn't the answer. But the test revealed exactly what the problem actually was. When Matt removed the Bentley coil and reinstalled the original Bugatti coil pack, he noticed it hadn't been seated fully onto the spark plug during the previous service. The connection was loose. He applied silicone spray to the seal, pressed the coil fully down and retested. No misfire. The engine ran cleanly. The fault wasn't the coil pack. It was an installation error from the service work. A connection that was almost right, but not quite. With everything resolved, wrap on, wheels fitted, TPMS cleared, indicators working, misfire gone, Matt drove the Veyron 150 miles to Dunsfold runway. The journey was completely faultless. No warning lights. No misfires. No hesitation. The car behaved like a perfectly functioning, road-ready supercar for the entire drive. At the runway, Matt ran through the top speed mode activation sequence. The car must be completely stationary. Engine running. All doors closed. Steering wheel straight. Tire pressures correct. No active fault codes anywhere on the dashboard. All conditions met. Matt inserted the 20-pound speed key. Turned it half a turn. Dashboard. Top speed mode activated. A key made by a locksmith in Leicester for less than the cost of a tank of fuel had just unlocked the most exclusive feature of one of the most exclusive production cars ever built. First attempt. No issues. Matt completed a practice run. Not a full top speed attempt yet, just a familiarization pass. Getting reference points for braking. Learning the surface. Confirming the car responded correctly at high speed. The run went well. He turned around for the actual attempt. The Veyron died. Here is the specific thing that broke. The fuel pump control module. The system that manages fuel flow rate, pressure, and delivery timing across all 16 cylinders developed a fault. The pumps stopped delivering fuel reliably. The engine would not stay running. No warning on the 150-mile journey. No fault code during the practice run. No indication of any kind. 150 miles of flawless driving. Then complete failure at the moment that mattered most. 3 things this video establishes. First, every single aspect of Bugatti Veyron ownership has an independent solution that does not require Bugatti's official network. The wrap, the wheels, the TPMs, the speed key, the diagnostics, the fuse hunt, the coil pack, all of it solved without the factory. Second, the 20-pound speed key replacing a $10,000 Bugatti component is the clearest example of what Matt has been proving throughout this entire series. The premium charged by manufacturers is not always for engineering. Sometimes it is purely for the badge. Third, the fuel pump control module failure is genuinely unpredictable. A 20-year-old car develops these faults regardless of how well it has been maintained. It could have failed on the way there. It could fail on the way home. That is the reality of running a car at this age. The top speed attempt is postponed. But the Veyron is visually transformed, mechanically improved, and fitted with a 20-pound key that works. It is closer to completing what it was built to do than it has ever been. The speed key works. The wrap is done. The wheels are on. One repair stands between this car and 253 miles per hour.